At the end of last week, we tried to cut through the clump of dust with the cantilever on the microscope, but that didn't work. So the next step was to test its conductivity. Basically, what Collins ended up helping me doing is called a capacitance test. The nanorods should function just as resistors, like really, really high resistance resistors. They block the current. If you have a voltage of, we used between negative 2.5 and positive 2.5 volts, there should not be a current passing through when the voltage is constant. So we were looking at this and the current was going up and down proportional to the voltage. All right. Then Collins says, okay, I know what we should do. We should level the voltage here. So this is at negative 2.5 and positive 2.5. And the thing is, because the nanorods are supposed to act as capacitors, what should have happened to the current is it should have decayed away exponentially, asymptoted at about 0. Done the same, well, it would have spiked up here and then again asymptoted to almost 0. As you can see, that didn't happen. So Collins and I said, there's a current here. That means that the dust is conductive. The sample's no good. Or at least this pad isn't. So I looked at this and I said, I've got to scrap my sample again. So I put it back in the piranha etch, which destroyed all of my nanorods, and I baked it, and I put it in the ozone cleaner. And then Professor Smith walked in and said, so it turns out that one of the cables wasn't connected, so whatever the machine was measuring, it might not have actually been your sample. So there's a chance that your sample could actually be alright to use for, like, real experiments. If you haven't already put it in the piranha etch, and I'm like... At that point, Professor Smith said, you know what, here, just take 2 completely new substrates, or at least substrates that you haven't been using before. Clean these off, see if you can get them clean. Then if you can use them for a sample.